Welcome back to Jurist3 YouTube channel. In today's video we're looking at the building or upgrading and modifying, or whatever you call it, of the controller that's going to be going with the Computator CT-1000 rotator that I have just built up, which you would have seen if you watched it in the previous video. So basically it is it was a Daiwa CR4 controller. It's now been severely upgraded. First thing that I've done is I've removed the original backing and the original blue colour. This one had blue. This is one of my little mods I used to do for the LEDs, put reflectors in there. So basically that has now gone, that's out, and has been placed with a much nicer, this has still got the covering on it, so we can't really see it that well, but it's one from a later model Yaesu 450 650 rotator controller. So basically I had to do a few mods, had to put the little scallops in, as you can probably see here, holes for the LEDs to go in. There's a bit of daggy going on here with the bit of plastic on the back and the front. I had to drill out the middle to accommodate the much bigger needle. So this needle will be going into there. This one has the little new LED in the kernel, which makes that blue. I'll get more into that later on. So basically I've already showed you that. So basically that has the LED for the brake already installed. So the brake engagement light. So I'm going to set that down on there. Now as for the new backing, the backing is again from the 450, 650 XL, or the later model versions anyway. It just so happens that this backing panel, which is steel, as you can see it's steel, has a blue covering on it, and just so happens to fit into the 4 mounting holes for the original lens. And if I just visually just got the original lens and stuck it over there, you see it all matches up. So basically that was an easy install upgrade. Yes, you have to drill a few holes here where the lens is screwed on, so you have to drill a few holes in the back of here to allow the screws to come through, with the screws that actually hold the lens. Since the lens normally has spaces between it and this, I don't need it in this, I need to get back as far as possible. The lens actually sits flush on here. So basically that's these screws now will actually go through further. So basically I had to drill holes into the 3 points that they normally mount, 1, 2 and 3, and they just go straight through. So it's a pretty straightforward upgrade. Again, I had to drill the holes for the LEDs and drill the center out. And it's this nice dark blue colour, so it's just sort of similar to that one. I wouldn't have minded putting this darker one in here, but it's got scratches and everything on it. I went, yeah, I'll just leave it out. Even just putting that in, it pushes the lens too far forward. So basically what I've done on the internals, basically I've wired up plugs and sockets to make things much easier to assemble and disassemble, and I'll get more into the other part of it in a minute. The where that is, up the back section down here, which all the PCBs and everything. So basically when I got this controller, it never had a pulley, or the pulley was lost. So basically when this goes back on, I haven't got it on at the present moment, this is the top pulley, it'll go on there, and we have the original belt, so that will be going back in. So this will be all fixed up in due course. I'll be putting the lens on and everything else, so we'll get to that. The top housing, I'll put that there for the present moment. The top housing is not bad condition. 2 fingerprints in here now, so that's in pretty good condition. So we'll sit that back there now, let it stand up so it doesn't fall over and trash things. I might just sit that up there as well. Now, since the Computator, if you watched the video, the Computator, which was a 24 volt rotator, its controller become faulty. I have tried I'm trying to fix it, but it will be no good for the latest and rendition of I'll get the right word, the right version now, because it's been converted to 100 volts because it's what I had. So basically I now have made this all suit the 100 volt. This is all the back panel sort of flaring out, and I have put in a new terminal block, or what they call it, terminal barrier. I put an IEC socket in, put an earth bolt in, and this is the early version, which doesn't have the multi-voltage input here. So this is, so I've basically done this is the old zinc-plated version, the gold one version. So basically I've cleaned it all off because it was pretty bad, and I've relabeled the whole thing. We now have the standard PCB in here, which I've upgraded with terminal blocks. I detested wires going everywhere, that you can't work on anything without breaking wires, so I'm using terminal blocks and everything. Basically, and same thing applies here. I've got a terminal block off the IEC socket to allow the pole back panel to be removed for working on. Here we have the BDS 35 brake delay board. Again, it already has a screw block terminal block on it. So these are all screw terminal blocks here as well. I put a couple of ferrite beads into the pot, coming in from the pot, so basically we can keep that pretty less noise free. It's like a double stack of beads. We have here the power supply coming out of there to go to the display, which I'll show you in a second. So that's basically all ready to go, yeah, this has a cover on it. It's an 8-way terminal block, but I don't use number 8, I'm using 7 terminals, so this little cover, we can't see it, it just snaps on. Like that. I also, which is as an option, I do have a flying lead to a 8-pin cinch socket, so you can unplug things easy if it's if you want. So that will just sit into here like that. So that's an option that I'll be providing at an extra cost, of course. So basically that's got that part out of the road. The 100 volt transformer is in its new position, and I put a 12 volt transformer in here, and again been plugged, wired, so I can remove the front panel. So basically we have the all the AC coming in and out, and from the switch and everything, which I didn't show you before. Oh, you probably can see it when I take this back down here. Woo! And there's the terminal block there for that one, push terminal block. I probably forgot to mention the side of this is has been upgraded a bit here. We can't see it down in here. Right direction. The gears have been reset and everything because they were split, so I put a little spring around them to contain and put more pressure on them. So that's one thing I've done in there and upgraded those. Put that back over there for now. And we also have, jumping around a bit here, we also have the little socket, 3-way socket to go in there. So basically I'm going to start assembling this, and basically, the next thing, what about this? I'm also putting in, for the LED illumination, for the needle and the display illumination, I've made a brand new board. It's for my wide LED version, but this one has a limit switch in it. This is called YLED DC plus limit. What I've done is I've adapted this board to just do display only, so I can actually individually control the brightness of the display and the needle. So basically I've left quite a few components off, which is all to do with the limit activation and change of LED colours with this board. So basically it's just a cut down board, well, sort of cut down the bench of the sorts, just less components. We put a couple of bridges in, there's one there, and there's another one across this one here. But other than that, and we just changed a few of the resistors around. So we put the variables in. Again, these are all terminal blocks, so we can unplug things quite easily for changing and putting things together. So it's a little board that I had made. I assemble it here when needed. So basically that's a little upgrade that I do to most of these C4s and CR-4s and CR4Ps, the remote control version, the preset version. So basically that's there. I've actually put a white line onto the direction switch, if you want to call it, rotation switch, so it just goes left and right and lock. I'll describe that more later on as we get through the build a bit. So yeah, so I shall leave it there for now, and I shall be back with a bit more assembled. Catch up. Okay, the display lens is in, but it still has the outer cover sheet on, so I don't get any scratches and stuff onto the lens. I've installed the LEDs, as you can see, one in there, one in there. They actually do push through a little bit further and hold in the actual rubber grommets better than when the other one went in, because just it has to be sitting a bit different. So what I'm going to do now is I've got to put my reflector over this, so I'll be back shortly to show you that. Okay, we now have the needle in, and I have put the reflector material over the LEDs, but I also put reflector material all the way around to contain as much light as possible into the lens, so it's not reflecting everywhere. Oh, that was flared out. So basically I now have all the LEDs in, as you can see. The actual IDC plugs are sitting here waiting for the PCB to go into. I shall put the front panel back on again. I shall see if I've got to clean. I've got to make sure everything's dust free, and then I will be putting the front panel on. So there we go, up there. Right. Okay, here we go. We now have things on, covers on. We've got the YLED DC less limit PC board in. I've got the pulley on. And basically we can move forward. All the wiring here to go. All these wires here go into the screw tunnel blocks. So basically they're ready to go. So there we are. We're moving forward. Back soon. Hey, we're back again. Rightio. I have just put the back panel onto the base. As you can see, just plug it in and basically just wire 5-6 wires into the bits and pieces here, and it's easy to service and work on. Makes it so much easier. So basically just snap it in, presto, it's all clicked in. This is all sealed as well. These are a 240 volt rated plug, and I've actually sealed them in the back with a glue sort of stuff, so you can't poke things in there and get electrocuted. So basically, yeah, it's all pretty well protected. And actually, I've got a heat shrink across onto the terminal, over the terminals. I've covered up as much as I can to keep prying fingers away. There we go. So that's where we're up to. There's a view from the top. It's all neat and tidy. I had to put a little bung in there to physically, which that one's not being used. That's where the preset one normally goes. So we have the display adjust down here. There we go. Moving forward. Rightio. We now, oh, this is heavier. It is now, front panel is on. Haven't got the top on yet, just thought I'd show you inside, all the wiring. The YLED PCB, YLED limit PCB I should say, without limit. Wiring to the back, front, side, and all the labelling. There we go. We shall put the top on, and this job is done. We shall catch you when I do the next. I'll probably do that at the end of this one. I'll attach the rotator and the controller at the bottom of this at the next. I might even do another video. Whatever. I'll catch you soon. Rightio, we're done. Everything is all together. Oh, I bumped the display. This display can be turned around, so I just bumped it again. Just go into there. So basically I've attached on my little test lead to make things easier to get this thing done. You can actually purchase it with another one. This is one that's sort of a permanent fit with eyelets on it. This one here has just fork terminals, just for quick and easy for myself. But this will be. You can actually purchase this particular one if you want to use a quick connect version. So basically, there's the controller all together. So basically, I'll plug him in now because we're going to be doing a run through showing it all working. Plug my cable in. And we'll turn him back around again. And it is also supplied, the rotator is supplied with a brand spanking new LTW 7-pin plug. So I'll bring the rotator over here. It's all labelled. It's all together. I've done all my realignment or alignment. I did have to pull it back apart again to get the alignment 100%. So basically that's all done. The mask clamper, as I probably showed you before, I've got it all here. I've got all the hardware sitting in this tray, which it's all been cleaned up and everything. So this is all ready to go. So it's all been painted. A bit too close, we can't see it. We don't want to hit the controller. So there we go. So we'll plug in the rotator. Got my test lead in there. So there we go. I might turn this a bit more that way. I'm going to bring this forward anyway to show you the LEDs, everything working. So basically we shall turn him on. I'll bring him up here. We'll turn him on. And you'll see the blue light in the end of the needle come up. And also, because LEDs will flash like anything on a video screen. So there's the brake engagement light saying the brake is engaged. Now once we put it down here, you probably won't see anything at all because of the way the light is around here. So we're just going to take this for a bit of a quick drive. So I probably mentioned this before. I like these controllers because they have a momentary and lock action. This controller does have the brake delay in this one for this rotator. So basically we can do a momentary, so if you listen closely you'll start the brake will disengage and basically we'll drive it for a couple of degrees and then we'll stop and you'll hear the brake re-engage. So here we go. So there we go. And then you hear the brake again. It's probably pretty quiet. So there we go again. So again, now we can go into lock mode where we just push down and push down even harder and we're in hands-free operation. So we'll take it all the way around to south. We'll stop at south. Now this rotator does have 20-degree overlap either side of south. So that was part of the reason why I had to pull it back apart again to try and get it to align to this. We're running right to the extremities of the potentiometer in this controller as opposed to what's in this. So we'll come back here, we'll basically stop it at south. There's south, the brake will engage. And then basically we can now go about 20 degrees past. There we go. Now it's about 75 seconds for rotation time if I remember correctly. I've written it down on my manual. I've written a whole brand new manual up for this as well to suit this controller and rotator, so I've done that as well. Very time consuming, but it's all done. So we'll take it up to west and we'll stop him again just to get off the lock pony. Just go hold it like that. I turn it back and the brake will engage, and you'll see I'll put some hands over that there. You'll see the LED should be on in there. You can probably just see it maybe. So we'll carry on around. Oh, wrong way. We're going right up here. Let's go this way. So the lock function is just a really good feature of this, which means you haven't got to hold it down. Again, just pull it back the other way and then just release. And if you want to, you can just go into momentary again. Just momentary left, momentary right. You can keep doing that and hold it down. It's not very heavy to switch. It's fairly light. And we'll stop it at east. Let the brake engage again. There's east. Let the brake engage. It's about a 3 to 5 second delay. The brake delay kit in this, there's 2 sets you got for it. You can actually make it a 3 or a 5 second. I've made this about a 5 thereabouts, or it could be about a 4 second delay thereabouts. So we'll take it to south, and we'll stop there, and then the brake will engage again, and then we can go into the overlap. There we go. Well, this one says it's about 15 degrees. It's about 15 to 20 degrees roughly. So we shall take it back around and park it back at north, and this video will then be done, and it will be all up for sale. This has been a long time coming for this rotator. There was many ways of doing the controller. I was going to use a different controller, and it didn't work out. And most of the reason was because of the overlap of that of 20 degrees. The other controller I was going to use, it just couldn't handle that sort of overlap. This one can just handle it, which is good. So we're moving forward, and we just got this all working. And so we're coming back to north, and you can just do momentary, sort of stop starting, momentary, just to go to north, and there we are. There we are, back at north again. Rightio, we shall catch you in the next project. Bye.